In this video, you will learn about atomic number, mass number, isotopes, atomic mass, and weighted average atomic mass. Let's look at the first topic, atomic number, which is commonly represented by uppercase Z. The number of protons in the nucleus of an atom is called atomic number of that atom. Atomic number is an extremely important property because it determines the identity of the atom. An atom with one proton is always hydrogen, and an atom with six protons is always carbon, and so on. Atomic number is so important that periodic table of elements is arranged in the order of increasing atomic number. These whole numbers at the top of the element is the atomic number. So for hydrogen, atomic number is 1. For helium, it is 2. For lithium, it is 3. And you can see the atomic numbers are increasing as you go left to right across this periodic table. Let's do some practice. Atomic number of hydrogen is 1, means every hydrogen atom has 1 proton. Atomic number of carbon is 6, means every carbon atom have 6 proton. Atomic number of copper is 29, means every copper atom have 29 protons. Similarly, atomic number of gold is 79. It means that every gold atom have 79 protons, and you can do this for all the examples that you have in the periodic table. In short, if you know atomic number, you know number of protons as well as the identity of the element. For instance, if atomic number 30 is given and you have to find the name of the element, what you will do is you will simply find number 30 on the periodic table, which is here, right? So you will find number 30 on the periodic table, and the element associated with this 30 is the element that you are looking for. Okay? Let's look at the relationship between atomic number and number of electrons. As you know that electrons are negatively charged and protons are positively charged. And based on Thomson's atomic model, the atoms of an element are neutral and have no electrical charge. Having both negative and positive particles inside the atom, that can only be possible if they are equal in number. So, in a neutral atom, the number of proton or the atomic number is equal to the number of electrons. So if the atomic number is given, for instance, the atomic number of chlorine is 17, this atomic number is giving you the information about the number of protons of chlorine, which is 17, as well as the number of electron for a neutral chlorine atom, which is 17 for this chlorine. Okay, so that's how you can find the number of electrons in a neutral atom. From this figure, what do you think is the rule for determining the number of electrons a neutral atom contain? You can pause this video, think about it, and then play the video to see the answer. Okay. From this figure, it is obvious that an atom has as many electrons outside the nucleus as it has the protons inside the nucleus. Because each electron has -1 charge and each proton have +1 charge. The overall atom must be neutral because equal number of +1 and -1 charges cancel each other. You have +6 inside the nucleus, -6 outside the nucleus will cancel each other, and the overall carbon will be neutral. Same is for the hydrogen. You have +1 inside the nucleus, -1 outside the nucleus. and they will cancel each other, and the hydrogen atom will appear as a neutral hydrogen.
Let's look at the next topic, mass number. Mass number is commonly represented by uppercase A. An atom's mass number is the number of protons plus the number of neutrons in its nucleus. With this information, we can write down an equation that is mass number equals number of protons, which is actually the number of atomic number, right? So mass number equals number of protons plus number of neutrons. Let's look at the example here. In this example, we have an atom of zinc that has mass number of 65. With this information, you have to find number of protons in the zinc atom. Remember, the number of proton you can find from the periodic table. These whole numbers in the periodic table, which is the atomic number, is also the number of protons. So if you have to find number of protons for zinc, 30 is the number of proton for zinc. So this is going to be your answer. Next, you have to find how many neutrons are in zinc atom. For neutrons, you need mass number. So mass number is given. Number of proton you just find. It will never change for the zinc, will always be 30. And number of neutron is what you have to find. So to find neutron, you will subtract these two numbers, and 35 is the number of neutron for zinc. 65 minus 30 equals 35. Next is, what is the mass number of zinc atom that has 37 neutron? Okay, so this time number of neutrons are given. So we are going to write down that number of neutron is 37. Okay. Number of proton for zinc will never change, will always be 30, right? So it will be 30. And when we add these two numbers, mass number is 67. So the zinc atom that have 37 neutron will have a mass number of 67. So you notice that number of proton will never change for an element, but it is possible that element may have a different number of neutrons in it. And we will see this in next few slides. Let's do some practice here. In the first practice, you have to write a chemical symbol for an atom that have 27 protons and a mass number of 59. So this image here will help you to write the symbol of an atom with its atomic number and mass number. So you will write down the symbol. In the subscript, you will write down atomic number, and at the superscript, you will write down mass number. Okay, so let's first identify atomic symbol. With 27 proton, atomic number, with this 27 proton, atomic number is cobalt, CO. Okay. Atomic number will be the subscript, and this 27 is the atomic number. So I'm writing 27 here. And mass number will be the superscript, and I have a mass number of 59. So this is going to be the chemical symbol for an atom with 27 atomic number and 59 mass number. Next, you have to write the chemical symbol for an atom that has 84 protons and 125 neutrons. So for this, let's first identify atomic symbol. With 84 protons, atomic symbol is here, polonium. So write down atomic symbol. Atomic number will be the subscript. For mass number, you need to add number of protons and number of neutrons. And when you add these two numbers, you have 209 as a mass number. Next, you have to write a chemical symbol for an atom that have 37 electrons and 108 neutrons. Remember, for a neutral atom, number of electrons is equal to the number of proton or the atomic number, right? So for 37, for 73, here is the symbol. So 73 is the atomic number as well. So let's write down this symbol, and then atomic number is the subscript. And for mass number, you are going to add number of neutron and number of proton, which is equal to the number of electron in this case, and you will have 181 as a mass number. Okay, in this example, you are told that an atom has a mass number of 16. Is this enough information to identify the element? Okay, so remember, mass number is equal to number of protons plus number of neutrons, right? And for the identity of element, what do you need? You need number of protons. So this number is given, but number of proton is not given. So this is not enough information for you to identify the element. Okay. Now, for the same information where before you were told that there's an element with a mass number of 16. Now, the extra information is given that with this mass number, it also contains 9 electrons. Can the atom be identified now? Let's see. So we have mass number, which is equal to number of protons plus number of neutrons, right? Mass number is 16. Number of proton we do not know. Number of neutron is given as 9. If you subtract these two numbers, 16 minus 9 will give you the number of proton, which is 7. With this number of proton, you can identify the atom now. Okay. With this number 7, if you look at the periodic table, you will see that nitrogen is the element that have atomic number 7. Okay. So that's how you can identify element for this problem. Okay. Let's look at the next topic. Next topic is isotopes. Isotopes are atoms of same element that have different number of neutrons. For example, the carbon atoms can have 6 neutrons, they can have 7 neutrons, or they can have 8 neutrons. But all these 3 types of carbon have 6 protons in it. And as long as there are 6 protons, all these atoms will be called as carbon atoms. Okay. The word isotope comes from the Greek word iso, means same, and topes means place. It means that these isotopes have same place in the periodic table. Okay. Here, use the given information to fill in the blank in the table below. We have hydrogen element given. Its mass number is given. You have to find what is the atomic number. So we can use this periodic table to find many of these blanks, and some of the information is given here as well. So let's see, what is the atomic number of hydrogen? So atomic number of hydrogen is these whole numbers at the top of the element, they are the atomic number. So atomic number of hydrogen is 1. Number of protons for hydrogen, atomic number is equal to the number of protons, so that is 1 as well. Now, number of electrons, hydrogen is neutral, so the number of electron is also 1. Now, number of neutrons, so mass number is the number of proton plus neutron, right? So if the mass number is 1 and number of proton is 1, how many neutrons can it have? It will have 0 neutron, right? For this hydrogen with mass number 1. And the isotope of hydrogen that we will write will be, we will write hydrogen 1, like this. Okay. Next we don't have the element given, but we have atomic number. With this atomic number, we can identify the element. So 20 is the atomic number for calcium. So element is calcium, mass number is 46, atomic number is 20. What is the number of proton? Number of proton is equal to the atomic number. So we're going to write down 20. How many number of electrons? For a neutral calcium, the number of proton or atomic number will be equal to the number of electrons. So we are going to write down 20 here. How many neutrons? So the neutrons will be mass number minus number of protons. Okay, so 46 minus 20 will give you number of neutrons. And how do we write the isotope symbol? It will be calcium, and this calcium has the mass number 46. So this will be calcium 46, like this. Okay, isotopes are identified by their mass numbers. Let's look at carbon 13. Atomic number for carbon 13, or no matter what carbon we have, will be 6, right? Always, as long as it is carbon. Atomic number is 6. Number of proton will also be 6. Number of electron for a neutral carbon will be 6. Number of neutrons will be mass number minus number of proton. Okay, so when you subtract these two, you have 7 neutrons. And how do we write this symbol? We write carbon 13 like this. Next we have carbon 12. Again, its atomic number going to be 6. Its number of proton will be 6. Number of electron will be 6. For number of neutron, you will subtract number of protons out of mass number. So 12 minus 6 will be 6. And the symbol that we write is carbon 12, like this. Next example, we have iron 56. So let's find where is iron in the periodic table. Here we have iron, and its atomic number is 26. So atomic number is 26. Atomic number is equals to number of proton. Number of proton and number of electrons are equal if the atom is neutral. For number of neutron, you will be subtracting number of proton from mass number. So you have 30. Okay, and we write it down, the symbol like iron 56. Okay, next we have element is not given, its mass number is here and atomic number is here. With 12 atomic number, we can identify which element it is. It is magnesium. Okay. Atomic number is 26. Sorry, mass number is 26. Atomic number is 12. Its number of proton going to be 12 as well. Number of electron will be same as the number of proton because it is neutral. For number of neutrons, you will subtract 12 out of 26 and you have 14 neutrons, and the symbol will be magnesium 26. Next we have gold, and here we have gold in the periodic table. So its atomic number is 79. Number of proton is same as the atomic number. Number of electron is same as number of proton if it is neutral. For number of neutron, it will be 197 minus 79. So you have 118, and the symbol going to be AU 197. Okay. For silver, here we have silver. Its atomic number going to be 47. Number of proton is 47. Number of electron will be 47, same as number of protons. For number of electron, you will subtract 108 minus 47. We have 61 neutrons, and the symbol going to be Ag 108. Now here you have to give full atomic symbol for an atom that has 16 neutron and atomic number of 15. Okay. Atomic number 15, if you look at the periodic table, you will find that it is phosphorus, P. Atomic number goes as a subscript like this. And here in the superscript, we will write number of protons plus neutron. So proton number is 15 plus neutron will be 16, and then when you add these two, you have 31. So this will be the atomic symbol for the atom that have 16 neutron and 15 atomic number. Let's do another example. In this example, we have bromine has two abundant isotopes, one with 44 neutron and other with 46 neutrons. You have to give full symbol, full atomic symbol for both isotopes. So if you look at the bromine in the periodic table, you will find that bromine have 35 atomic numbers. So I'm writing 35 in the denominator or in the subscript, not the denominator. Okay. Now we have two bromine isotopes. We have to find what are their atomic masses. For atomic mass, sum of proton number plus the neutron will be the atomic mass. So 35 plus 44 is the mass number for this bromine, and 46 plus 35 is the mass number for this bromine. Let's look at atomic mass. The actual mass of an atom is called atomic mass. The atomic mass is expressed in the unit of AMU. The observed mass is slightly less than the mass of the proton, neutron, and electron that make up the atom. And this difference is called mass defect, that is during the combination of these particles by conversion into binding energy. The atomic masses on the periodic table takes isotopes into account, weighing them based on their abundance in nature. More weight is given to the isotope that occur more frequently in nature. Here we have three isotopes of hydrogen. atomic mass of hydrogen 1 that have 1 proton only and 0 neutron is 1.0079 AMU. Mass of hydrogen 2 that have 1 proton and 1 neutron is 2.101410, and mass of hydrogen 3 that has 1 proton and 2 neutron is 3.01605 AMU. According to International Union of Pure and Applied Chemistry, IUPAC, one atomic mass unit is defined as 1/12th the mass of the carbon atom. Why is the carbon standard? It's a good question. Carbon is commonly combined with other elements. Additionally, carbon-12 isotope is highly abundant in nature. And after many years of arguing, chemists and physicists agreed that carbon-12 would be the best unit of measurement for atomic mass. Previous standards included hydrogen and oxygen. However, scientists had difficulty using these elements as a standard due to the distribution of their isotopes. Our next topic is weighted average atomic mass. The weighted average atomic mass of an element is the average value for isotopes of the element. It takes into account the percentage abundance of these isotopes. I have the formula here. Atomic weight or weighted average atomic mass equals percent abundance of isotope 1 divided by 100 to get rid of this percent sign, multiply mass of isotope 1 plus percent abundance of isotope 2 divided by 100, multiply mass of isotope 2, and then plus if there is another isotope of that element. Okay. So we do this step for all the isotopes, and then at the end we add the masses. The average atomic mass of an element can be found on the periodic table, typically under the element symbol. Let's calculate the weighted average atomic mass of an element. In order to do that, we have few steps. Step number 1 is determine the mass of each isotope. Step number 2 is determine the percent abundance of each isotope in the compound from the information given. Next is for each isotope, divide the percent abundance by 100% and multiply the result times the mass of that isotope. And then add all the portions obtained in step number 3 to get the weighted average atomic mass. Let's do this example. We have to calculate the weighted average atomic mass of bromine. Okay. Bromine consists of two isotopes, bromine 79 and bromine 81. Okay. Some information is given from bromine 79, which is its atomic mass is given, okay, and its percent abundance is given. Similarly, for bromine 81, its atomic mass is given and percent abundance is given. So let's plug in these numbers in the formula. Let's first write down the first section of the formula for bromine 79. Okay. So the percent abundance for bromine 79 is 50.69% divided by 100. Then you multiply it by mass of isotope 1, which is 78.9183. Okay. Let's keep it separate. And then here you have the percent abundance, 49.31%. This is multiply 80.9163 AMU. So this set that I have is for bromine 81. Next you will do the math. Okay, so this is the answer, and once you have your answer, you are going to check your significant figures. So the first step that we did is multiplication and division. So here you have 4 sig figs, in this you have 5 sig figs, again you have 4 sig figs here and 6 sig figs here. If you have to round it to the number of sig fig, it will be the least number, which is 4. So 1, 2, 3, and 4 is your significant numbers here. For this one as well, it will be 4 significant, 1, 2, 3, and 4. Next, you are doing addition. When you are doing addition, you are going to look for the decimal places under this bracket. So under this bracket, for this you have 2 decimal place, and here you have 2 decimal place. When you round, you will be rounding it up to 2 decimal place, and your answer going to be 79.90 AMU. That's going to be your answer.